Sowing Seeds in the Desert by Masanobu, Fukuoka, Chapter 2, Part 2. An alternative view of evolution. Perhaps it went like this. The Creator rolled the seeds of every living thing into clay pellets and gave them to messengers to scatter randomly. Some seeds were programmed to become active soon after the birth of the earth. Others were programmed to thrive in water. Some were suited to mountains, some to deserts. The seeds that were designed to become human beings were made to come to life during the later ages of the earth. Millions of seeds were broadcast at one time, and the living things of the world took on various forms. Some became microorganisms, some became green plants, and some became animals that could run around. Scientifically, we could say that these seeds germinated when conditions were right for their germination, and only those that took forms suited to their living environment developed and survived. Those seeds that fell into the sea became seaweed, coral, and sea anemones. Others became shellfish and shrimp, and all lived together. The seeds scattered in marshes became cattails, some changed into catfish or eels, and in some cases the same seeds became frogs, turtles, or snakes. Living things bearing similar genes but manifesting differently became forest trees, while others became the birds that lived in the forest trees. At the same time that the vegetation on earth increased and large trees grew in abundance, large animals such as tigers and elephants made their appearance. Microorganisms, plants, and animals are all genetic siblings, of course, but each appeared in a different costume. In some ways, this may seem like a distorted dramatization of Darwin's theory of evolution. The big difference is how we think about the passage of time. In my mind, millions and millions of years appear as a momentary flash. Consequently, the innumerable varieties of living things have not originated at different times in different places, but rather at the same time and in the same place. Nature is one body. We can say that while human beings and insects are a part of nature, they also represent nature as a whole. And if that is so, when we harm plants, microorganisms, and insects through large-scale conventional agriculture, to use just one example, we are harming humanity as well. I would like to propose a Dharma wheel theory of biological development as an alternative to Darwin's flat, single-plane theory of natural selection. I will call it the Dharma wheel theory of flux in all things. The Dharma wheel can be seen as a representation of natural law. Nature expands in all directions, three-dimensionally, and at the same time, as it develops, it converges and contracts. We can see these changes of expansion and contraction as a kind of wheel. It is like the universe, three-dimensional, always expanding and contracting, spinning in space and heading in an unknown direction. At the creation, along with the birth of the rest of the universe, the earth and all the living things on it were born as a single unified body, with a common fate. Everything regarding the roles, the aims, and the work of each of them originated and was concluded in the same instant. All things were designed so that one is many, the individual is the whole is perfect. There is no waste, nothing is useless, and all things perform their best service. There is another aspect to this dynamic, spinning, expanding, and contracting three-dimensional and multifaceted Dharma wheel. Its center, the hub, is forever motionless and forever one. Instead of seeing the distinctions among the things of this world, if we look at that base, it is all one, and the purpose of all things is the same. Naturally occurring hybrids in my rice fields. 10 or so years ago, I tried crossbreeding non-glutinous rice from Burma with Japanese glutinous rice in order to develop a new variety suited for natural farming. The two rices are extremely different in character, but the genetic characteristics of the parents were intermingled, so I wound up getting 20, 30, sometimes several hundred different varieties. When I arranged these varieties, I noticed that their characteristics formed a continuum. There was non-glutinous rice close to glutinous, intermediate forms, glutinous rice close to non-glutinous, and in some which glutinous and non-glutinous grains were mixed together on a single head. Some rice plants reached a height of only 10 or 12 inches, while others were giants, more than 5 feet tall. There was also a succession of different colors of rice, white, red, and blackish brown. Some were flavorful, some not, some powdery, some sticky. In this situation, it was impossible to say which was good and which was bad. I also came to question the value of distinguishing between glutinous and non-glutinous rices, and even between paddy and dry field culture. After years of crossbreeding rice in my fields, however, I finally concluded that on a natural farm, people do not need to create new varieties by artificial crossbreeding at all, since the insects that most people consider as harmful were creating new varieties on their own. In my rice fields, I noticed that after locusts and other insects had chewed round holes in the small grains, just as the heads were sprouting, slugs, snails, In my rice fields, I noticed that after locusts and other insects had chewed round holes in the rice grains, just as the heads were sprouting, slugs, snails, cutworms, and other creatures came along and crawled over the grains at night. They ate down to the stamens in the holes, after which wind-blown pollen from other varieties adhered and achieved fertilization. In other words, rice, which is said to be self-pollinating, can also be pollinated by other plants, and in this way new varieties arise naturally. In a conventionally farmed paddy field sprayed with insecticide, natural hybrids do not occur. On a natural farm, however, they can easily survive, and there are many chances for new varieties to appear. In the end, there is no need for people to imitate nature by carrying out artificial crossbreeding. It is all being done for them. Alongside crossbreeding rice with rice, I experimented with crossbreeding rice with weeds such as Deccan grass, Echinocloa and foxtail, wild rye, and was thinking that if that went well, I would try more combinations with foxtail millet and Chinese millet. But my original purpose was not to study rice for its own sake. I was really just amusing myself by going in the opposite direction of what was being recommended by agronomists at the time. I was doing a reverse breeding in search of atavisms, potentially valuable species that had been lost over the centuries. With today's technology, I undoubtedly would have succeeded should I have taken my research any further, but I did not have the slightest intention of setting foot in the domain of the biological sciences. I stopped at the point of confirming the possibility. When I saw insects were creating a succession of new varieties in the fields of my natural farm, I thought it would be better to leave things up to them, and I stepped back. I also came to the conclusion that the classification of plants, placing them in species, genus, family, and order, was not only an imposition on the plants, but of no use to human beings. We will be better off simply appreciating all the diverse forms nature has provided and not interfering. With the current technology of gene exchange, it has become easy to create different varieties of fruits and vegetables. I call it the mad course of genetic engineering. Soon humans will acquire the technology to turn animals into plants, plants into animals. But not only is such scientific meddling unnecessary, it's dangerous. If we follow Darwin's thinking that one form of life evolved into the millions of life forms that exist today, then it seems justifiable to add a few new species or genes here and there. People may hope that they can create even better organisms and that these new forms will assimilate with nature's creatures, but the result will be the opposite. By creating new organisms through biological engineering, people take the risk of throwing the natural plot of the world play into confusion. Even if we understand that the functioning of the genes of living things is determined by the way the 4 bases of DNA are arranged, it is optimistic to suppose that genetically engineered plants and animals will not get out of control. There is no such thing in this world that we do not understand. There is so much in this world that we do not understand, not only about the shapes and forms of living things, but also about their temperaments and spirit. When we try something like creating new life forms and then turn them loose in the environment, disastrous side effects are certain to occur. We just do not know exactly what these side effects will be yet. Abandoning what we think we know. 10 years ago, I paid a visit to the niece of Albert Einstein near Central Park in New York City. When I asked her if Einstein thought that time and space really existed, she replied that although he saw time and space as relative, he probably could not give an opinion about their reality. That might well have been his answer if I had been talking to Einstein himself, but we will never really know. What we do know is that he said that mass and matter are energy. We know that extensions of this idea led to enormous energy explosions by splitting the atom. Nuclear physicists realized that if atoms could be split, they could also be fused. And so, brushing aside Einstein's second thoughts, they created the hydrogen bomb. Einstein must still be drifting around in purgatory, burdened with responsibility for his part in this tragedy. I cannot speak for him, of course, but I imagine he would enjoy a conversation about the limitations of human knowledge. Some years ago, Fritjof Capra, a professor of theoretical physics at the University of California who also lectures on science as a holistic discipline, visited my hillside hut. He was troubled that the current theories of subatomic particles appeared to be incomplete. There ought to be some fundamental principle, Capra said, and he wanted to express it mathematically. In search for this elusive fundamental principle, he had found a hint in the Taoist concept of yin and yang. He called it the science of the Tao, but he added that this alone did not solve the puzzle. He had likened the lively dance of subatomic particles to the dance of the Indian god Shiva, but it was difficult to know what the steps of the dance were, or the melody of the flute. I had learned about the concept of subatomic particles from him, so of course I had no words that could directly dispel his frustration. It is one thing to think that within the constant changes of all things and phenomena there must be some corresponding fixed laws, but humans cannot seem to be satisfied until they have expressed these laws mathematically. I believe there is a limit to our ability to know nature with human knowledge. When I mentioned this might be the source of his problem, Capra countered it, saying, "I've written more than 10 books, but haven't you written books too, thinking knowledge was useful?" "It is true that I've written several books," I responded, "but you seem to have written your books believing that they would be useful to other people. I have written mine with the idea that books are not useful at all. It appears that both of us, from the West and the East, are investigating nature and yearning for a return to nature, so we are able to sit together and have a meeting of the minds. But on the point of affirming or negating human knowledge, we seem to be moving in opposite directions. So we probably will not arrive at the same place in the end. In the end, it will require some courage and perhaps a leap of faith for people to abandon what they think they know.